This is part 3 of a tutorial created for students studying in the Ocean Naval Architectural Engineering discipline at Memorial University of Newfoundland's Faculty of Engineering and Applied Science in St. John's, Newfoundland, Canada. Today's tutorial covers the syntax and structure used for inputting commands within the GHS environment. In this tutorial, we're going to discuss the methods GHS uses to identify file paths, specify parts, and we're going to introduce the command structure used to select parameters and populate those parameters with both generalized or specific values. Moreover, we're going to discuss how to add comments to run files to keep your files organized, or provide legacy support to you or your team when they're trying to run files in your absence. By the end of this tutorial, you should be able to use the part and load commands, apply basic command structure, alter path name, and comment a run file for other users. Okay, so in previous videos, I've highlighted the user interface of GHS and its various point-and-click pull-down menus and selection options. These menus make it very easy to get started with GHS, particularly if your programming background borders on non-existent. However, at heart, GHS relies on an underlying command structure to drive its operation. This has been apparent each time we've selected a menu option. Even casual observation of the command output line would have revealed that the software takes your point-and-click request and inserts the appropriate command into the command line. As a result of this command structure, we can really leverage the power and efficiency of understanding the software by creating and modifying run files if we're familiar with the language used to create a command sequence. GHS commands are input into the command line in a logical, structured manner. The software then interprets these commands to apply myriad mathematical operations to the geometry in the run file. The result of any command is displayed in the output dialog box. Consequently, all commands in GHS share a basic format beginning with the command name and followed by any specified parts. For commands requiring more than one value, we can distinguish between values using commas as a separator or delimiter. After inputting the value sequence, we can modify the parameters of a command. In the video clip, you can see that the command name is highlighted in blue, while the part and value specifications are depicted in green. Finally, the parameters are indicated by yellow font. Let's take a look at our example command, load FOday 1.0. and break it out by its constituents. The load command instructs GHS to load the part identified within the parentheses. In this case, we're loading a tank we've named in the model as FOday, which is simply an abbreviation for the fuel oil day tank. Lastly, we specify a value for the action, in this case 1.0 or 100% of the possible value. In summary, this command, load FOday 1.0, tells GHS to take the part identified in our model as the FOday tank and load it to 100% of its capacity. Don't get too hung up on the part naming and how we assign identities to geometries, etc. We're going to get into the minutiae in a later tutorial. For now, just focus on the command structure. Now, anyone who has ever dealt with programmers knows that they are a particular subspecies of engine nerd that appreciates brevity even more than the rest of us do. Thus, commands can be entered in an even shorter form by using the appropriate two-letter abbreviated form. You can always check the help menu for a quick reference as to the possible GHS commands and their short forms. Suffice to say, a number of them take the form of the first two letters of the command name. For instance, we could re-enter our command using its short form by typing out LO and open parentheses, the part name FOday, followed by a closed parentheses, and complete the command by specifying a value of 1.0. Then push enter to input the command. As commands become more intricate, the need may arise to specify multiple values representing, for instance, a part centroid and its weight. When a command accepts multiple values, these values are separated by commas. Since the software is looking for combinations of parentheses, slashes, and commas in order to parse out the various constituents of the command, it is ignoring spaces within the command. Subsequently, you can use spaces as a means of breaking up your command to make it easier for us humans to track visually, without interrupting GHS's ability to interpret the command sequence. However, for now, we're going to stick with the important but simple load command in order to focus on a command's basic structure. Since we've now outlined how a command works, let's take a moment to discuss the next element of the command structure, the part. Parts comprise individual subsets of your model and will always be specified following a command by using parentheses. Proper part identification in your model is important because it enables us to discretize our model by assigning different part names to the subsets. This allows us to separate, identify, and select multiple part names using commas to select elements en masse. The final aspect of the command structure I'm going to mention is parameters. Parameters are specific instructions to a command that provide direction regarding how that command executes. If and or when you are using parameters, you can distinguish between parameters using / marks. So feel free to read up in the help manual and experiment on your own with that. Otherwise, don't sweat it too much. I'm going to discuss all of this in more detail later on when we dive into part and model building using GHS. The ability to select multiple parts concurrently is a very powerful aspect of the software. Using the Boolean wildcard operator, the asterisk on your keyboard, we can identify any part names that match a given pattern. For example, let's try our load command again, only this time we'd like to identify and select every fuel oil tank on board the vessel. If we've been consistent with our naming structure in our design, we can enter the command load FO* 1.0 and instruct the software to identify all tanks having the first two common characters FO, and then load these tanks to 100% of their tank volumes. Now, a quick cautionary note. Operators such as this are direction dependent because they look for patterns. As a result, you have to make choices that are logical. In other words, binary decisions that a computer would make. For instance, the wildcard operator can come at the end of a string of characters, such as in our tank example. However, if you try to begin a string with the wildcard, GHS is going to be understandably confused and reject your command. If you do something like this, it's no harm, no foul. You're not going to catastrophically crash GHS or anything like that. This is more just a caution so you don't wonder why your command is not working. Alright, finally let's discuss the ever so exciting world of file paths. We touched a little bit earlier on file structure in tutorials 1 and 2, but there's still a few details left to cover now that we've familiarized ourselves with the software. So let's do that. Aspects of GHS's formatting are still governed by DOS. That means that certain features, such as the naming scheme for files, are limited to 12 characters. Check out the example. If I try to create a revision of our trusty project Nighthawk, choosing the name Nighthawk version 2, GHS refuses the file name. Well, it happily accepts Nighthawk as a valid file name. To skirt this issue, we can use quotation marks around the file names or descriptions to amplify or lengthen the name. Consider the example on the slide. Using the directory command, I can insert the file name Nighthawk damage stability into the GHS data path on my hard drive simply by enclosing the entire path in quotation marks. GHS uses a series of user input commands to instruct the software. Oftentimes, some of our instructions may involve asking the program to pull information from a number of files, while writing to other files, before saving report files, among other things. These multiple interactions allow us to use pre-existing codes with multiple geometries employing only minor modifications. The run instructions can be written or later modified using a plain text editor of your choice. The type of instruction files we create are called run files. Run files execute a series of commands sequentially exactly as they are detailed in the file. To execute a run file, we can start GHS, navigate to the directory containing the run file, and select the run file. Alternatively, we can run a file directly from the command line by typing the command run, followed by an opening quotation mark, the name of the run file, the file extension .rf, and a closing quotation mark. Similar to other programming languages, individuals who are creating GHS run files can provide comments within the file that supply amplifying or clarifying information. This is very useful if you are creating a code that you may shelve for an extended period of time, if your code may be used for a number of different scenarios or vessels, or if other members of your team may later use the code. To denote the start of a comment, we use a diacritical mark. However, unlike many other codes, GHS does not use the apostrophe, it uses the grave accent. For many North American users, this key is located on the same key as the tilde, adjacent to the number 1. For multilingual keyboard users, you've probably already got a better idea of where the grave accent is than I do, so I'm not going to speculate. Let's take a look at the example on screen. The major takeaway from this example is that all new lines of commentary must have an opening diacritical mark. However, no comment line requires a closing mark. If you look at the second example on screen, you'll see a command asking GHS to load the diesel fuel oil tank on the port side to 100% of its capacity. You'll also see how a comment might look, instructing a novice user as to what the intent of that command is. For comparison's sake, consider the third example. In this case, I have written a GHS command. However, the diacritical mark preceding the command comments out the command, meaning GHS will ignore the input. This trick may prove helpful in the future when we're trying to troubleshoot run files without having to delete and rewrite large sections of our code. Now that we've examined command structures in GHS, let's open the program and look at how it applies to a typical run file. So I'll begin by opening GHS and navigate to the fishing vessel demo file provided by GHSPort. So now that we have the geometry file open, the first thing we'll do is use the parts command in order to bring up a list of the parts that comprise the geometry file. In this case, you can see that there are a number of tanks, sail, and hull pieces that have all been used to build the geometry file for GHS to process. Next, by using the load command, we can then enter one of the tanks, in this case, the fuel oil day tank to the starboard side. That's FOday.s. Enter a value of 1.0 and press enter. We can then use the status command and type in status tanks, and that'll bring up in the command output line the fuel oil day tank to the starboard side and show us a load of 100% of its capacity. And you can see that we also see the associated longitudinal, transverse, and vertical centers of gravity, as well as the weight of the tank as a result of the load we've put on it. Now, by using the load command again, this time entering a value of 0.0, we can empty the tank. Examining the status tanks again, we can see that no tanks are now loaded, as displayed in the command output window. Similarly, we can use the wildcard operator load FO star 1.0 to load any tanks in the vessel that begin with the pattern of characters FO. In this case, you can see that we actually had 4 tanks. We intended to load only the fuel oil tanks, but we've also loaded a 4-peak tank on the center line and the forecastle centerline tank. This is why it's important to check the status of your tanks frequently to ensure that you're only loading or unloading the tanks that are intended for your analysis. However, by using the load star command with a value of 0.0, you can see that in the command output window, we're able to set all tanks to empty. Or by using the command load star 1.0, we're able to set the load in all tanks on board the vessel. You can see the response from GHS in the command output window, where it will depict load set in all tanks. Alternatively, by using the command status tanks, we bring up the status of all tanks on board. Looking at the command window on the screen, we can see that the load has been set in all tanks. Finally, once again, by using our load command with the wildcard operator and a value of 0.0, we can reset all our tanks to their baseline empty level. GHS lets us know that this command has been performed by providing the prompt that says all tanks empty. I'm going to take a moment to demonstrate commenting in the GHS environment. Beginning with the command load FOday.s 1.0, I then insert a grave accent, followed by an explanation of the command intent, as you can see in the video capture. Running the status tanks command, we can see that the software has executed the command unhindered by my comment. Alright, so what we've discussed here today is a primer for command structure. I've gone into some detail with respect to how a command is structured and input into the program, and we've looked at 2 of the fundamental queries in GHS, being the load and status commands. On your own, I'd like you to open the GHS demo geometry file for the fishing vessel. Try opening this model using both the file navigation method and the command line input method. Once you've successfully loaded the geometry file, call up the list of parts that comprise the vessel. Now, use the wildcard operator to load all water tanks. If you've gotten that far, load the fuel oil day tank on the starboard side to 50% of its capacity. Finally, using the status command, check your tank status and note how the output is populated in the command window. This concludes the 100 series of our GHS tutorials. In the next tutorial, 201, we begin looking at how GHS can be used to create model parts and how we can use other third-party modeling software to expedite the process. Thanks for watching, and if you have any questions or feedback, please leave them in the comments below and one of our admins will get back to you. If you like what you're learning here, please hit the like button. And hey, if you're really feeling motivated, feel free to hit the subscribe button. We're constantly trying to publish new, innovative content that redefines how students and professionals learn and consolidate their engineering and naval architectural knowledge. So it's always nice to know that someone out there in the digital landscape is actually watching this stuff.